Welcome back, Flare community. Today, I want to talk about the Flare network, and more specifically, the consensus algorithm which it uses, which allows it to be scalable far beyond its competitors. The Flare network is a first of its kind, using a modified version of the Federated Byzantine agreement to solve the Sybil attack. Now, some of you may be wondering what a Sybil attack is. A Sybil attack is defined as a small number of entities counterfeiting multiple peer identities so as to compromise a disproportionate share of the system. In other words, an adversary tries to get a large number of nodes, which may or may not be randomly selected, to appear and function as distinct nodes. Now, if we take that to proof of work, this basically means a Sybil attack could be carried out by having 51% of the mining power. If you control the majority of the mining power, you can essentially rewrite the history and also further transactions on the network. In regards to proof of stake, a Sybil attack could be carried out by an entity which holds the majority of the native token of the network. But here's where the Flare network is very different. We can see here from the white paper that Flare is a distributed network running the Avalanche consensus protocol, which is adapted to Federated Byzantine agreement. Now, Federated Byzantine agreement is similar to what is used by both the XRP ledger and also the Stellar blockchain. As you know, very scalable, very fast, very efficient. But it uses this modified version of the Avalanche consensus. Federated Byzantine Agreement, FBA, are a class of scalable consensus protocols that do not rely on economic mechanisms to secure the network. The resulting network is scalable, safe, and decentralized. It is freed from the constraints of potential safety conflicts of utilizing economic means to solve the Sybil attack. Now, something that really blew my mind recently was this tweet here by Sean Rowan, who is actually the co-founder and chief technical officer of the Flare network. Now, I'm sure you will agree, this is absolutely incredible. This is a live block explorer, or it was live at the point of recording, and it is based on the Coston testnet. Now, as you can see here, the average block time is 333 milliseconds, so 1/3 of a second. And you can also see here that the transactions are maybe 1 transactions, 2 transactions, 3 transactions. So it seems like the block size is very small, but in regards to its speed, it's very fast indeed. Now, we can compare this to the XRP ledger, for example, which has an average ledger interval of around 4 seconds, just under 4 seconds. Now, in contrast, you can see the amount of transactions here, 49, 41, 45, they're a lot higher, and this is incredible as well. You know, don't get me wrong, they both have different use cases, and I just think it's very important to know that Federated Byzantine Agreement really is a revolutionary consensus algorithm. It's far ahead than proof of work and proof of stake, and it really is what makes the Flare network so special, this ability to scale, which is something which all other smart contract platforms are really struggling with. Now, I'd just like to bring your attention to this video here, which is to do with the Avalanche consensus algorithm. And the CEO here, he actually does a great job of very simply describing how the Avalanche consensus works. So let's just listen to this, and also bear in mind that it's the Federated Byzantine Agreement consensus, which has been adapted with Avalanche. So let's give this a quick listen.
So what we're going to do is we're going to build a protocol that is designed to tip The worst thing you want for a consensus protocol is for it to be stable in the middle. You don't want that. You want it to say either this happened or that happened. You want it to fall to one of the two sides. And the core operation is so darn simple, as I promised you, that I can just illustrate it to you. It's very simple. We are in a very big crowded stadium. We don't know who's in it. But we start out, we look around, we pick a small number of people around the stadium. 5 of them, let's say. Somewhere between 5 to 10 will do. And then we poll them. We say, look, you, A, B, C, D, E, what do you think? What shall we pick, red or blue? And these nodes then will respond. They can say red, red, blue, red, blue. When we see this, we go, okay, it looks like the entire stadium is tilting towards red, at least from my own perspective, based on one round of polling. And so what I'm going to do now is simply add my weight to what I perceive to be the heavier weight. So I'll throw my weight behind the red after this poll. It's dirt simple. Now, this repeats itself for everybody else. You do the same, and so on and so forth. And you can see that even if we start out in the worst possible scenario of a 50-50 split stadium, after one round, we're not going to be at 50-50. The chances of that are astronomically small. After 2 rounds, even smaller. After 3, we're talking about probabilities so low that it's more likely that your phone will misbehave and miscompute than you will stay at 50-50. We will go from a 50-50 split to a 51-49 split, most likely. And after a 51-49 split, we're going to find ourselves in a bigger split, 53-47, and so on and so forth. This thing is designed to tip. It's not going to stay in the middle. And as it tips, as more and more people shift to one color or the other, we're going to have first a phase change. So the speed with which we move towards one direction is going to increase and increase. And at some point, we're going to reach the point of no return, where the entire stadium either has red cards on top of their foreheads or blue cards.
So I thought that was a really great way to describe the Avalanche consensus protocol. So I'm just going to finally wrap up here by a short post on the XRP chat by Luke, aka Thinly Spread, and he made this quick message here about scaling for value, Fleur versus Solana. So Solana has been getting a lot of attention recently, so it's very fast, don't get me wrong, but it is lacking this ability to scale. Thinly Spread goes on to mention, it is missing one crucial element, the secret sauce, if you will, that other Generation 3 chains simply cannot even address yet, scaling for value. Now we see why in plain sight. The Flare tokenomics is not tied down with the security of the underlying chain or consensus mechanism other than Spark as a network-level anti-spam mechanism or postage stamp like XRP. Now, just to expand on this a little bit, each transaction on the Flare network will burn a small amount of Spark. This is used as a deterrent to prevent malicious actors from flooding the network with pointless transactions to create some sort of artificial congestion. As we continue here, Flare has essentially taken the finest elements of Hedera Hashgraph, Avalanche, and XRP and Stellar through Federated Byzantine Agreement and created something that can scale out without endangering the security of the overall network through economic-based attack vectors, and done so with entirely new groundbreaking features that turn value interoperability on its head via the Flare time series Oracle and F asset system. And I feel like Thinly Spread here, Luke, he's hitting the nail on the head. So I'm not sure what you guys think about this, but I think it's highly encouraging. We're seeing all of this development come to fruition, and I just feel like the Flare network is not just revolutionary in the sense of the F-Asset protocol, the state connector, and all these other great things like the FTSO, but fundamentally at a consensus level, the very first Federated Byzantine Agreement smart contract network. It really is leaps and bounds ahead of its competitors. It's extremely fast, and we have this to look forward to in the coming weeks and months. So thank you all so much for watching. If you're yet to subscribe, please feel free to do so. And until next time, I'm out.
Mission Control, we have liftoff.